Okay, good morning all. I hope you all understood the last session. We deal with the mechatronics. Today we are going to discuss about sensors. So sensors are important part. Okay, before going to sensor, we will look at what a system is. So system, system, system means, okay, you can take it in the sense you have a box, so we are giving some input to the box is giving some output, so box is called a system. So in that system it need two subsystem to perform its action. One is called the measurement system and the other one is called control system. The measurement system means it will take the values from outside through some sensors. So sometimes it will be temperature, if it is okay, if it is your air conditioning system, so you will set the temperature of your room temperature, let it be 21 degrees Celsius. So every time the system will check what is the temperature at the room. If it is not 21, what it will do, it will on the compressor and flow the, if it is okay, let's see this one. If the temperature T is greater than 21 degree, what it will do, it will switch on the compressor will be on. When means it, so control system will say that this is less than greater than 21, so compressor should on. When T is less than 21, what the control system will do, it will cut off the compressor. So that's the way it manages the temperature. So these are the two main systems we can see in a mechatronic system. So going to sensors. Sensors play a vital role in communicating or taking value from the physical world to the system, to our system. Then it processes the value. After that it gives an output in the form of some controls. So going in detail to sensors, what are the types of sensors, what the sensors are doing, classification, it's very important. You have to go in detail of this session. So looking to that sensor, a sensor is an element in measurement system. So using sensor we are quantifying the things that acquires a physical parameter and change into a signal. So it will interact with the physical parameter, then it will change. After interacting, it change that into a signal. So that is what a sensor do. Okay, if you take an example, sensor is used to measure physical quantities such as position, force, distance, strain, vibration, temperature, acceleration, such kind of physical parameter it can sense. So thermocouple senses the temperature. As I suggested the example of AC, what it will do. In air conditioning system, the temperature have to be measured from the room, right? That is through a sensor called thermocouple. So that what the sensor do. Thermocouple, what it do? It will interact with the physical world. It takes the mechanical input for the sensor and it produces an electrical signal as an output. If you look at the sensor only, we'll go in detail. Now the word, okay, often we are using a word called transducer. Sometimes we use sensor, sometimes we use transducer. So transducer, it's saying that we are just elaborating the term sensor. Actually it interacted with two domains, sensors. One form of, it will convert one form of energy to another form, something like that, mechanical energy to electrical energy. If you want to say mechanical to electrical, suppose a weighing machine. Weighing machine, when we are putting a load, the weighing machine will show you the weight of the load. So how it is happening is a strain gauge when is there below the platform. So whenever you are over the platform, the strain gauge will get compressed, so it will produce a electrical value. So the mechanical compression converted into electrical signal. That's a two domain. So one form of energy, mechanical energy, is converted into electrical energy. In that sense, we are using sensors. We can replace the term with transducer. Okay, here the term transducer is often used synonymously with the sensor. However, the word transducer is used for sensing element only. Sensors is used for sensing element plus any associated signal conditioning circuit. Okay, so the main difference, if you look at what is the main difference between sensor and transducer, is sensor gives only convert the mechanical input to electrical output. Sorry, transducer convert mechanical input to electrical output. But if you want to call it as a sensor, that signal how to be the signal how to be conditioned, which can be readily used for a circuit. Then that we call it as a sensor. So there are two main category of transducers. One is passive, the other one is active. The passive sensors means the sensor doesn't consume any power for its function. Such kind of sensors are called passive. Active sensors means active sensors need some electrical power to be consumed for its function. So we have to power the sensor. So such kind of sensors are called passive active sensors. So examples of passive transducer or sensor are resistive, inductive, capacitive transducers. So if you take capacitor, capacitor doesn't need any external power supply. Whatever power we are what the use of the capacitor is as a function as a storing device. So it stores the electrical energy. So for storing the electrical energy, it will not consume any electrical energy. That's what it means. It's a passive transducer. And active means you can say that a thermocouple or photovoltaic cell means which consumes an electricity for its functioning. The type, if you categorize the sensors, the main types of sensors you can say active and passive. Just now we communicated the term was different. Transducer, the thing means ideology was same. It's a required external source, power source, excitation voltage for active sensor. Passive, almost entirely provided by measuring signal without any excitation mode. So measuring signal itself will, we can take a use the power of the measuring signal and can function. That's the main difference. Now digital versus analog. Analog signal means it will the transducer or sensor output will be analog, and digital means sensor output will be digital. Null and deflection method, that is the output. Okay, suppose we are giving an input, electrical input to some device means sensor, and again it reflects back the electrical output. uh, so if the input and output phase change is there, then there are devices which will not show the phase change. There are devices which will shows the phase change. So that is what, if the phase change is not there, you can call it as null. The signal versus sensor is conditioning to minimum in deflection. Okay, then some of them are deflected which need a conditioner, some deflected. There are the two types. Then comes static. Okay, Now the main classification is over. Now if you look at the performance, how means we want to go deeply analyze um, a sensors or transducer. What are the parameters we have to keep in front for checking a transducer or sensors? So we are testing or counting the efficiency of the transistor or sensors by two different way. One is static characteristics and dynamic characteristics. First we will go through the static characteristics. It's very important. You have to take it seriously and go through all detail. Static characteristics. Static characteristics. Static characteristics of an instrument are considered for instruments that are used to measure unvarying process condition, almost static. So the process conditions are not at all changing, just static. That kind of parameter we are um, um, with that come under static. Let's go ahead. Range. Range means so it's a difference between minimum and maximum value of quantity. Suppose a distance. We start from here, we are going to end there. We start from 0, we start from 0, we end at 100 meters. So the distance will be counted as 100 minus 0, so 100 meters. So that's called range. Example, load of a cell can be 0 to 10 to 10 kilonewton. So that is a range. So sorry, I just made a mistake. Range means the capability of the device to measure. So in the sense, okay, suppose our device is capable of measuring a distance. The minimum distance I can measure is 0 and the maximum distance I can measure is 100. So that's what the range indicates. Span means it is the difference between the maximum and minimum value of the quantity. That's what I first said. So span of my device is what? 100 minus 10. Or if you are going to take a weighing machine, here that's I to the example. We can measure 10 kilo newton minimum, 100 newton maximum. So the span will be 100 minus 10, that is 90. Now comes what is error. Deviation of true value of load. True value from the derived value is called error. Error is measured value by next true value. So if you take a you want to check whether our scale is accurate, means scale have error or not, we will take another scale which we confirm that this is up to standard. Then we take the weight on that one, so we take that as a true value. Then we take our scale, we can putting that one in our scale, that is the measured value. So what is the difference between the true value and measured value? It is counted as error. Accuracy. Accuracy means ability of an instrument to respond to its true value of a measured variable under reference condition. So we put same condition, then we uh, true value. Okay, we have two scale. One scale is true value. We are sure that it always give true value. Now we are going to check our scale, weighing scale. So once we put 10 kilogram on the true value, we got true value 10 kilogram, then we change to our, it gives 9.999 kilogram. So uh, first try we have an error, then again repeatedly we check with another 15, again we found some error, again check with another one, we found an error. So that is what accuracy is, how much near to true value it is producing. That is what accuracy. Again, the term accuracy and precision is always confusing. Accuracy and precision, it differs in the sense here. Okay, here precision, that is exactness. Degree of precision is called degree of exactness. If you take 10 kg at one weighing scale, means our true scale, you got 10, then our scale 9.9. Again we will check the weight on the our scale repeatedly many times. So on repetition of the cycle, how much time it gives? 9.99. That is what it called precision. Repeatedly we are testing one load and how it is respond to that. So precision is very important. Sensitivity defined as the ratio of magnitude of output to magnitude of input. So we give some input, so how fast it gives the output, that is what sensitivity means. Sensitivity again in a broader sense, output by input. There are non-linearity, it depends upon the value of input quantity. Okay, so if you take a to check the analyze the sensitivity of a sensor, so we have this will show the ideal curve, and this is called the actual curve. Then the curve of, okay, the whenever we increase the input, the output is also slightly increasing goes. Actually we expect that input and output should be in this way only. So that's what our expectation, but it happened in this way, a curve manner. So non-linearity percentage is maximum deviation. There is a we expect to be linear, but the curve formed is non-linear. Now non-linearity, how much non-linear our values are, or our curves are, that is maximum deviation of input by maximum full scale input. That is what we call as non-linearity. Then hysteresis is the difference in the output for a given input. So mostly if you take in the mechanical term, hysteresis means this way we are loading, and this way we are unloading. So suppose we have a weighing scale, minimum weight of 10 kilometer, maximum 100 kilometer. So what we will do is we will load the scale first, 10, 20, 30, 40, 50, 60, like that we will reach up to 100 kilometer. So we will plot the values whatever, then we revert this one. We will reduce the load, 100 minus 10 minus 10 minus 10 minus 10 minus 20 minus 30, that means 100, 90, 70, say 80, 70, 60, 50, like that we are reducing up to 10. So if you look at this one, we will get a loading unloading pattern this way. So this is called a hysteresis. So our error means the hysteresis. This is our error means what? The maximum deviation in the two curves, it's called error. Now comes the term reproducibility and repeatability. Repeatability is defined as a closeness of agreement among number of consecutive measurement of an output for some values of input. So repeatably, once we give one input, it produces one output. Again we go another input, another output, again one input, another output. So repeatably, again we repeat the first one. So how it is, okay, it is used to describe the ability of an instrument to produce the output for repeated application of same input value. Okay, suppose, okay, we are going to a petrol bunk. We are filling, most of them used to fill with the round figure for 100 rupees, 500 rupees. So every day the petrol bunk is repeatably doing the function of 500 rupees calibration. So what will happen? Okay, you give him 500, and again the machine have to be measured the equivalent volume of petrol, so it have to be put in your tank. So repeatably it have to be the exact amount. It should not be less, it should not be high. So that is what reproducibility. Then reproducibility may be defined as closeness of agreement among repeated agreement among repeated measurement of output over a period of time. Then dead zone means the largest range of value of a measured variable which is instrument does not respond. So maximum value, that will be 100 kilo newton. Beyond that it can't function. So these are the things, and these are what you call static characteristics. Then going to dynamic characteristics. Okay, okay, dynamic characteristics here. Okay, dynamic it may be practical case. The parameter to be measured are time varying. In the first case, time is not at all a parameter, but here we are taking time as a parameter. Varying time, they are dynamic in nature. Thus output of an instrument is also time varying. Behavior of the instrument under such a time varying input output condition are called dynamic response of instrument. So we are taking time as a one parameter, then we analyze our sensors. So that is what dynamic character indicates. So going to dynamic character, we have to look at steady state periods. The output magnitude whose magnitude is left in repeated cycle. So we can say that it's tick tick motion of a clock. So your clock is moving to 360 seconds. Each second sweep will be same, and it is repeatedly same based upon the time. So that is a steady state periodic. All the periods are same only. And transient means the periods will not be same. 1 second oscillation, see, we cover 360 within 1 minute. So 360 by 60 will be the one side, so that will be constant for throughout the time. So here transient means what? This means output signal will vary based upon time. Then we can call that variation will be in the first order, maybe in the second order. Different variation can be observed. Then overshoot means maximum amount which did move far beyond the steady state is called the maximum value. Time constant means what? Transducer, how fast the transducer react to the input change. If you give an input, how fast it responds. Suppose capacitor will not respond so fast because capacitor have to be get charged for the discharge. So a response time will be there. Then response time is defined as a machine instant response to change the quality or time. Okay, rise time, it is a time taken for an output to some specific range. Okay, some devices need rise time. It have to be get consume the energy. After that it will be your output. Setting time taken for an output to settle with some percentage. Okay, types of input. Okay, now if you go to the input, mainly we have step input, then impulse input, sinusoidal, ramp. So some inputs are step form, some inputs impulse, one pulse, then after minute time another sinusoidal and RAM. I think today we can stop here. Thank you. Again, you have to write an assignment on this topic, means regarding senses completely up to this class, and submit it by today evening 5 o'clock.